Now let's work on non-homogeneous equations and undetermined coefficients. This is one of the most important parts of differential equations. Now we will be starting on non-homogeneous equations, which we will be encountering a lot in the future. So please listen this lecture carefully. Now, what is a non-homogeneous equation? A non-homogeneous equation is where you have a second order differential equation. Obviously, this concept is set for second order. We have a second order differential equation, and after the equal sign, we have something. Okay, it could be a function of x, it could be a function of t if you're using t as your variable, but you will have another function on the right hand side. So it dramatically affects your solutions. And since this is a non-homogeneous differential equation, we have two main methods of solving these kinds of differential equations. One is that we use variation of parameters, which is super useful, and we can use this to almost pretty much any function we have on the right hand side. So it's really useful, and it's a nice method. It does require to make a lot of work, but it's definitely a good method to solve these differential equations. And we have undetermined coefficients method, which is a lot more easier. But it doesn't apply to every function. So on the right hand side, sometimes we will have functions like tangent or logarithm or other kinds of functions that will not be able to, we were not going to be able to solve it using undetermined coefficients, where we will have to use variation of parameters. Some questions may specifically ask you to use undetermined or variation of parameters. So it is really important to master both of these methods to solve differential equations. Now, a brief description of these methods include our general solution for the non-homogeneous equation is built up onto this addition. We find our y homogeneous. And y homogeneous is basically treat this equation as the right hand side is equal to 0. Okay, write the same equation. I double prime plus pxy prime plus qxy. Okay, imagine you have this homogeneous equation. Now if you have this equation, it's actually pretty simple to solve. You're just gonna build the characteristic equation, right? And after that, you're gonna solve for the roots of r, and then you're gonna either have distinct real roots or equal real roots or complex roots. Okay, and this will generate you different scenarios, different solutions, and those solutions will be called y of h. Okay, this is called y of h, y homogeneous. And then we're gonna have a particular solution, and this particular solution is for when you use either of these methods, variation of parameters or undetermined coefficients, where you use a solution to explain the right hand side. Okay, y homogeneous, it doesn't work for these equations. You cannot go ahead and plug y homogeneous and get the right answer. It's not a solution. However, y particular is a solution for the differential equation, which is a really interesting fact. And y general is also the solution of the non-homogeneous differential equation. Now let's cover what undetermined coefficients is and how we can use it. So for undetermined coefficients, I want you to be familiar with this example guess table. Okay, if you can understand what's going on, you can basically figure out for every single function. So if we have these are for the right hand side. Okay, right hand side, where we have any kind of function. Okay, we could have any function there. If let's say you have a polynomial, and this polynomial is a second degree polynomial because the highest order, highest derivative of highest exponent of x is 2. So you will have a polynomial ax squared plus bx plus c. Well, we don't have an x term here. Well, it doesn't matter. As long as you have you're just gonna determine the order of this polynomial, and once you get the order, you're just going to build the standard polynomial of that order. For example, if you had x squared itself, you would still get the same thing regardless of that too, because it's a second order polynomial. We have a third order polynomial, and the third order polynomial will generate you the third order polynomial, and these a, b, c's are just constants, and we're gonna try to solve for these constants, and these will be eventually our y particular. Okay, this side is for your y particular. So a third order polynomial will generate you a third order polynomial. If we have something like e to the 5x, okay, you're gonna have a e to the 5x. So notice you're not changing the exponent and e, but you're multiplying that with a constant. Now, very interestingly, if you have a sine or a cosine function, let's say you have a 6 sine 3x, what you're going to do is you're going to have a times sine of 3x plus b cosine of 3x. Okay, every time you include a trig function, you're going to have both of these no matter what, but the input, the 3x inside the parentheses, will be the same with this one. For example, we have 7 cosine of 2x here. We will have a sine of 2x plus b cosine of 2x. Okay, x squared plus 5 e to the 5x. Now, these are really important. These are much different than what we did, because we have a second order polynomial, but we're also adding an e to the exponential function. Okay, so you're just gonna add the polynomial. Okay, we have the polynomial term ax squared plus bx plus c, and we're adding accounting for this one, which is a de to the 5x, which is an exponential. And from the table here, we know that exponential table corresponds to the same exponent but with a constant. So we're gonna have this. Also, make note that always put different variable names for these constants. So if you have a b, c here, don't put a c or a for this, so you don't get messed up. Over here, for this one, now we have a multiplication. All right, we have a combination of two different functions. Well, we're just gonna do the same thing pretty much. We're gonna write this x squared plus 5 as a second order polynomial, ax squared plus bx plus c. This will be our polynomial, and for this parentheses, we're gonna have a trig function. So we're gonna have not cosine of 4x, but we will have multiplied with a. Actually, you don't want to use a since we use a, so you will use d cosine of 4x plus e sine of 4x. Obviously, these e's or d's, it doesn't really matter which one you use. You can put any letter you want. Cosine and sine, the order doesn't matter. Also, you can put sine first or cosine. It's just gonna give you the same result. The only thing matters is you're both putting sine and cosine. Okay, you want to put those, and you also make sure you don't make a mistake in the input. Okay, this is 4x because this is 4x. Okay, since the cosine, the input of the cosine is 4x, you will have 4x for both inputs in sine and cosine. So this is pretty much the table for every function you need to use for undetermined coefficients. Now let's work on a second order. What would we do? How would we solve it? How does undetermined coefficients work? So first of all, you're gonna go ahead and find your y homogeneous, which is when you set this equals 0. Then once you find your y homogeneous, you're gonna go ahead and find your y fundamental. Okay, it's a set of solutions. For example, we had, I don't know, c1 e to the x plus c2 e to the, let's say, 2x. Okay, this is one of the distinct real root solutions we had previously. Our fundamental set of solutions will be e to the x comma e to the 2x. Okay, something like this. And you want to have that on your hand, your fundamental set of solutions. And then on the right hand side, you're gonna start building your undetermined coefficients using yp, your particular solution. So you're gonna get yp using undetermined coefficients. And then what you want to do is you're gonna get that, and you're gonna check, okay, check with y of f. Let's say you have, I don't know, e to the x here, okay? Well, you're gonna check, does it contradict, does it create resonance? Well, in YF, the fundamental set of solutions, you do have an e to the x, and you have an e to the x here, so that's the same thing. So you don't want that, no. So you're gonna go ahead and multiply with x, okay, or whatever you're dealing with. If this is a t, you're gonna multiply with t. And then you're gonna go ahead and check again if you have that. Do you have that? No, we don't have x e to the x. So this is a good solution, okay? So you're gonna check if independent, okay? We're gonna say if it's independent, good, okay, it's good. If not, multiply with x or t. Doesn't matter which, it does obviously matter, but it depends on what kind of variables you're working with. So it depends on the problem. And then check again, okay? And then if it's independent, you're good to go. If not, multiply with x again until you get your actual y particular. Okay? Now, once you get your y particular, you might have something like e to the ae to the 5x. Okay, this is not good enough because you have a constant term. So once you are at this point, you're gonna go ahead and plug this yp, okay, plug this into the differential equation. And once you plug it, also finding the second and first derivatives, you're gonna set this equation, and then this equation will give you the constant for a. Okay, so after you get that, at the end, you find your, let's say you find your a to be 5. Okay, so yp equals to, let's say, 5e to the 5x. So you will have your general solution yg equals to yh plus yp. Okay, so you're gonna get your yh. I just randomly wrote this yh, so you're gonna have, let's say you have this, and then you have this, okay, your particular solution, and this will generate you your solution for the differential equation. So I know it might seem a little complicated, but it's okay. We're gonna go ahead and solve two very good problems, and these problems will help you better understand what's going on and how we can solve these problems. Alright, now I'm starting up with an easy one. We have y double prime minus y prime minus 2y equals to 4t squared minus 2t. Now, once we have this, the first thing you want to do is set the homogeneous solution. Okay, let's hit the homogeneous solution. This is homogeneous solution. So we're gonna put the characteristic equation and solve for yh, the homogeneous solution, which we did previously many times. So the solution for this differential equation is, you're gonna factor this. This is the quadratic. You're gonna have this. So r1 is 2 and r2 is -1. So the solution will be c1 e to the 2t plus c2 e to the minus t. Okay, this is your solution, your yh. This solution, as I told before, doesn't apply for the entire differential equation. This is not a solution for this differential equation. This is for the homogeneous version of this differential equation. So that's why it's called the yh. Now, let's build the fundamental set of solutions here. And the fundamental set of solutions will be e to the 2t, comma, it's going to be e to the minus t, okay? These are the fundamental set of solutions. So, and if we have e to the 2t, or e to the minus t on the guess part, we will have to multiply with t to make this resonance get fixed. Well, thankfully this is not the case here. We have a polynomial of a second degree, so we can guess our y particular to be a t squared plus bt plus c. Now this is our guess for the particular solution, and now we're gonna check with the y fundamental. Does anything cause any resonance? So I don't have any of these terms common in my fundamental set of solutions, which means we are good to go with this solution. We don't have to multiply with t. Good. Now that we have our y particular guess, we're going to go ahead and find the first and second derivatives and plug this into the differential equation to find a, b, and c. Now the first one will be yp prime is going to be equal to 2at plus b, and yp double prime will be 2a. Okay, now let's go ahead and plug this into the differential equation. 2a minus 2a minus b, see how I multiply with -1 for these two, minus 2yp, okay, minus 2 times at squared plus bt plus c equals to 4t squared minus 2t. Nice. And these two a's are gonna be cancelled out, so we will have negative b. Let's distribute this. Minus 2at squared minus 2bt minus 2c equals to 4t squared minus 2t. So let's gather like terms together. So we will have minus 2a times t squared minus 2b times t. Actually, let's do it like this. Okay. And minus b plus 2c. Okay. Okay. Now, what we can say now is that we have a 4t squared on the right hand side, and on the left hand side our t squared term is negative 2a. So this means negative 2a must be equal to 4 and a must be equal to negative 2. So this is how you get your constant coefficients. So we have negative 2b for t, so this means that b must be equal to 1 because we have a negative 2b. Okay, if you make this a plus and you have this negative in the parentheses, you will have a negative 2b in front of t. Okay, so negative 2b equals to negative 2. Okay, negative 2b equals to negative 2, so b equals to 1. Okay, and this last solution is going to be, we have a negative b plus 2c, and that's equal to 0 because we don't have any constant terms on the right hand side. So we're going to say negative b plus minus 2c equals to 0, and we know that b is equal to 1, so we can just plug that in. Negative 1 minus 2c equals to 0, and this gives us negative 2c equals to 1, c equals to negative 1 over 2. Okay, so now we have all of our coefficients for this differential equation. So we can go ahead and plug for yp. Okay, what was yp? Let's just carry yp over here. Actually, it's just second degree polynomial, so it's gonna be yp will be equal to at squared plus bt plus c. And now if we plug these constants in, it's going to be negative 2t squared plus t minus 1 over 2. Okay, this is our yp. Now our solution for this differential equation will be yh, homogeneous, plus y particular. So y general equals to yh plus yp. And now our yg is going to be, our general solution will be the homogeneous solution first, c1e to the 2t plus c2e to the minus t. This is the homogeneous solution. And now we're going to add the particular solution. So plus negative 2t squared, or you know what, let's just make it more simpler. Let's not add that and do negative 2t squared plus t minus 1 over 2. And this is the solution for your differential equation. Now here's a very nice problem. This problem is testing your understanding of multiplication of two different guesses. And then we're going to have a resonance here. in this problem. So this resonance is also gonna test if you know what to do when you see a resonance. So let's start with that. So we imagine you have this as a homogeneous differential equation. Okay, this is the first step. So we're gonna have the characteristic equation just like this, and we know that this characteristic equation, the r's are gonna be imaginary roots. We don't have any real roots here, so the solution is gonna be negative b plus or minus square root of 4ac, b squared minus 4ac. So b squared is 4 minus 4 times 1 times 5, which is going to be negative 16 here. So we're going to have 4i, okay? And divided by 2, because our a is going to be 2. So r1 comma r2 is going to be, and I'm just going to simplify this, negative 1 plus or minus 2i is going to be your roots. So your solution will be for yh is going to be e to the real part, negative t, multiplied with c1 cosine of 2t plus c2 sine of 2t. Awesome. Now that we have this, we can go ahead and build our fundamental set of solutions. Our fundamental set of solutions will be, we're going to multiply this e to the minus t, because you just don't consider the constants. Other than the constants, everything is part of the set of solutions. So we're going to have e to the minus t cosine of 2t plus, and comma, not plus because this is a set, e to the minus t sine of 2t. And this will be your fundamental set of solutions. Now let's go ahead and find what y particular is. Y particular, now we have a e to the minus t here. So first of all, we want to do a times e to the minus t, okay? And multiply that with, now we have a cosine of 2t, so that's guess is going to be sine, actually b sine or cosine, it doesn't matter which one you put first, b sine of 2t plus c cosine of 2t. Okay, I'm just writing random constants. A, B, C are just arbitrary constants. So now what we want to do is we're going to multiply these to get the y particular, but before we do that, we have an a and a b here. So if you multiply an a and a b, you're still going to get a constant. So you actually can forget about this constant here, because it doesn't really matter if you multiply a constant with a constant, because you're still getting a constant. And I'm gonna yeah, b and c are fine. So y of p is gonna be b times e to the minus t sine of 2t plus c cosine of 2t times e to the minus t. Well, now we want to find our fundamental set of solutions for this one, and it will be e to the minus c sine of 2t, comma, e to the minus t cosine of 2t. Okay? Y fundamental for p, ypf. Okay? Well, here's an important thing we want to do. We want to check this. Okay? And when you check this, you have the same guys in here. These are literally the same people, the same functions we're dealing with. So this is not good. This is called resonance. Okay, this is called resonance. These are linearly dependent. They're the same. So you're gonna go ahead and get your y particular and multiply with t, because our variable here is t. Everything will be multiplied with t, so you can get rid of that resonance. So y of p is now going to be bt e to the minus t sine of 2t plus ct cosine, actually let's write e first, ct e to the minus t cosine of 2t. Now we're going to check again. Well, obviously we don't have a t to the minus t sine of 2t or t to the minus t cosine of 2t in the fundamental set of solutions up here. So we're fine with this solution. This solution is definitely going to work. Now let's plug that into the differential equation. Now when we plug yp terms into the differential equation, we will have b equals to 1 and c equals to 0 from algebra. And once we do that, we will be able to solve for yp, which will be t to the minus c sine of 2t. And since we had y of h previously before, when we solved the characteristic equation, we got this. We will now be able to solve the differential equation. The general solution will be the addition of yp and yh. So our solution for the differential equation will be t to the minus t sine of 2t plus e to the minus t times c1 cosine of 2t plus c2 sine of 2t.